Alright, hey guys, what's up? The goal for you tonight is for you to be able to solve proportions using cross multiplication. Alright, now, something I want you to know is that ratios, ratios, what we've been dealing with, they're proportional if they increase or decrease by the same factor or the same divisor. Alright, and next slide is going to show you what that looks like. So, let's move this out of the way. First, are these ratios proportional? Alright, look. I've got 3 over 4 and 9 over 12. Now, I know these look just like fractions, alright, but one way to write ratios is to write them like a fraction. So, we want to figure out if these are proportional. Well, the easiest way is to look and see, well, how do we go from 3 to 9? We can only use multiplication or division, alright? How can we go from 3 to 9? Well, we can do 3 times 3 and get 9. And so whatever we do to the top, we have to do to the bottom. 4 times 3 is 12. Yes. Since we can do times 3 to the top and times 3 to the bottom to get our new ratio, those two ratios are considered proportional. Alright, even though these numbers are higher, 9/12, technically, guys, if you simplified it, it would be 3/4 also. Okay, so these are proportional, or equal to each other. Alright? This set of ratios, how can we go from 10 to 2? Well, we can divide by 5. And so since I divide the top by 5, I can divide the bottom by 5. 25 divided by 5 is 5. 10 divided by 5 is 2. Yes, those two ratios are proportional. Now, let's say you come across two ratios like this. I've got 4 over 9 and 8 over 14. Alright, well, how can we go from 4 to 8? Well, we can do times 2. Well, let's do times 2 on the bottom then. 9 times 2 is 4. No, that's not right. So we can cross this out. What's 9 times 2? It's supposed to be 18. Alright, so since that does not work, it's supposed to be 18. But since that doesn't work, those two ratios are not proportional. They're not equal to each other. Alright, and this last set of ratios, 12 over 28 and 5 over 7. Well, we can't go from 12 to 5 by dividing by a whole number, but we can go from 28 to 7. We can divide 28 by 4 and get 7. But 12 divided by 4 isn't 5. 12 divided by 4 is 3. So does that work? No, it does not. That top number over the 7 would have to be a 3 to make these two sets of ratios proportional. But since it's not a 3, they're not considered proportional. Alright, but ratios don't always increase or decrease by whole numbers. Alright, I wish they did, because that would make my life and your life a lot easier, but they don't. And in that case, we have to cross multiply. Alright, so this is the main goal of the notes you're taking tonight. So, I know there's a lot up here, alright, but let's look at these top 4 first. Alright, are these ratios proportional? Well, look, we can't go from 21 to 28 or 12 to 16 by multiplying or dividing by a whole number. Alright, we can't. So in this case, what we want to do is we want to cross multiply. And when we cross multiply, if we get the exact same value, when we cross multiply 12 and 28 and 16 and 21, it turns out that those two ratios are proportional. And if you guys actually reduced these two ratios as much as possible, you could simplify 12 over 21 into 4/7, and you could simplify 16 over 28 into 4/7. And you guys know that 4/7 equals 4/7. So, yeah, those two ratios would be proportional. But in this case, we're using cross multiplication. When I do 21 times 16, I get 336. And when I do 12 times 28, I get 336. If they equal the same thing, those two ratios are proportional. Alright, this is pretty much, I think, the easiest way to figure out if two sets of ratios are proportional. Alright? And again, ratios, even though they can be written like fractions, ratios can contain decimals. Alright, so I've got 3.2 over 12.8 and 1.4 over 5.6. I want to figure out if those two sets of ratios are proportional. So I'm going to cross multiply. Alright? 12.8 times 1.4 is 17.92, and 3.2 times 5.6 is 17.92. Since they equal the exact same thing, they're proportional. Next set, 4 over 6 and 10 over 14. Well, let's cross multiply. 4 times 14 is 56, 6 times 10 is 60. They don't equal each other, so they can't be proportional. And the last set, 4.8 times 13.5 is 64.8. And then we've got 7.6 times 8.1 is 61.56. They are not equal to each other, so they are not proportional. Alright, pretty easy. Now what I want you to do is on your own, these 4 sets of ratios, I want you to use cross multiplication to figure out if each set is proportional. So pause the video, I'll be right back. Alright, so hopefully you guys paused the video. I'm going to go over the answers. First thing I'm going to do is, well, the only thing I'm going to do is I'm going to cross multiply. Got 33 times 20 and 50 times 14. So I'm going to bring that equal sign down. That's still going to be there. Alright, when I do 33 times 20, I'm going to get 660. So, write 660. And then when I do, 50 times 14, I'm going to get 700. Alright, and are those two values equal to each other? No, they're not. Since they're not equal to each other, they are not proportional. Alright? Next set of ratios. Alright, let's cross multiply. When I do 10 times 27, I get 270. So let's write that in here. 270. 18 times 15. 270. So, both those values are equal to each other, so they must be proportional. Yes. Alright, next set. Now we're dealing with decimals. Okay, so we're going to cross multiply. I've got 2.1 times 23.14, or sorry, 23.4, and I've got 12.6 times 3.9. Alright, so when I cross multiply, 2.1 times 23.4, I'm going to get 49.14, and I'm going to get the exact same thing when I multiply 12.6 times 3.9. Since those are equal to each other, these two sets of ratios are proportional. Alright, and our last set of ratios. Alright, let's cross multiply. Bring the equal sign down. 7.2 times 8.4. That's going to give me 60.48. And then I'm going to multiply 9.1 times 6.3, and that'll give me 57.33. Those two values not equal to each other. So guess what? They're not equal to each other. They're not proportional. Alright? That's that. And the last thing I want to go over with you guys before this video is over is teach you how to solve for a variable when you're dealing with two ratios. Alright? And really this is very similar to questions you're going to have to deal with when you're dealing with word problems and ratios. Okay? So for example, let's say you travel 36 miles in 8 hours. Alright, and I want to figure out how many miles you can travel in 10 hours at that same rate. Okay? Well, we know this is 10 hours, but we don't know what this value is. Since we're dealing with miles, I'm just going to call that variable m, alright, for miles. I'm going to cross multiply. Alright, oh, and before I do that, notice something, class. See how both of these values are in the same unit measurement? Alright, these are both hours. The top are both miles. Same thing with the rest of these. See how our numerators, alright, or our top numbers, in this case though we're dealing with ratios, so these are inches, both on top, miles will both be on bottom. And over here, seconds will both be on bottom, meters will both be on top. Alright, so the same type of measurement is going to be on bottom, and the same type is going to be on top. Alright, that's very important when you set up two ratios equal to each other, especially when you're solving for a variable. Alright, so if hours are on bottom, any unit or any number, any value that is in hours needs to be on bottom. Those stay on bottom. Miles, if you're going to put them on top, all the values that deal with miles need to stay on top. Okay? So, anyway, now, when we cross multiply, 8 times m is 8m, 36 times 10 is 360. And look what we have here, class. It's a one-step equation, which you guys know how to do. So, how do I get rid of the 8? I got to divide by 8, and I'm going to do it on both sides. When I divide 360 by 8, I get 45. So this value, m, is 45 miles. Alright, next one. I've got 3 inches is 5 miles. That is a ratio you might see, for example, on a map. Right? Every 3 inches equals 5 miles in real life. Well, let's say on a map, 2 cities are 18.6 inches apart on the map. But you want to know how many miles apart those 2 cities are in real life. Well, we'll set these two ratios equal to each other. I'll do 3 times m, which is 3m. I'll do 5 times 18.6, which, awesome, whole number, we get 93. That'll be easy. Then to get rid of the 3 times m, we gotta do the inverse, which is divided by 3. And whenever I do to one side, I have to do to the other. And when I divide 93 by 3, I get 31. So m, our variable, must equal 31 miles. Alright, now this last one. Using these two examples to help you through it, I want you to solve for m. Alright, this is nice. Our variable staying the same, m. Alright, so try and figure out what m is. Go ahead, pause the video and solve it. Alright, I'm back. So, this is what you should have done first. Okay, cross multiply. When you do that, let's see, equal sign is going to come down. 8 times m is 8m. 51 times 60 is 3060. And then we need to get rid of, oh, where's my red marker? There we go. We need to get rid of that 8 attached to the m. How do I do that? I divide by 8. And since I divide by 8 on this side, I need to divide by 8 on the other side. So these cancel out. M is all by itself, which is exactly what we want because that's what we're solving for. And when I divide 3060 by 8, I'm going to get 382.5. And we're dealing with meters, so I'm going to label my answer, alright, with the unit measurement. In this case, meters. Alright, so that's what you should have gotten for your answer. Tomorrow, when you come in, we are going to be dealing with pretty much word problems using cross multiplication, because I can just give you problems with numbers in them all day and you can cross multiply and solve, but you need to be able to apply this method to real life situations. Alright, so be ready to do that when you come into class, and I will see you all tomorrow. Hope you're having a great night. Later!